A warm welcome to everyone to the very first session of Education Outreach Program. Actually, it's a new initiative by GirlScript Foundation. We are very excited to start this journey with an insightful session titled Pipelines to Prompts, Unifying MLOps and LLMOps for Scalable and Responsible AI. Today's session will be led by one of our guest speakers, Ritesh, who brings a wealth of knowledge in the space and will guide us through the topic with the experience and expertise. Further, without any delay, over to you, sir.
Thank you for the introduction. So let me share my screen, then we can begin with the session. Just give me a second. Okay, if my screen is visible, just let me know.
Yeah, it is.
Okay, fine. So present it. Okay, so what all this session is all about, and what we are going to see in this particular session, so we are going to discuss the agenda, and we are going to get into this particular ecosystem, MLOps and LLMOps, and how it is being utilized in all across the different large firms and large companies, how they are utilizing, and the basic idea, what is MLOps and what is LLMOps, and how it is being utilized in any sort of company, whether it is a banking company, or whether it is a kind of e-commerce firms, or any sort of companies. Like most of the firms in the today's world is using Gen AI. Most of the firm is using the AI. Most of the firm is using all the sort of traditional machine learning models, all the sort of deep learning models, all the sort of natural language processing, and so on. So so from there, we have came to a specific thing which is known as MLOps. And if you know about DevOps, what is DevOps, and if you know a little bit about DevOps, how DevOps is being utilized, so you will be getting an idea regarding the MLOps. So in this session, I will give you a basic understanding regarding what is MLOps and how it is being utilized in the LLM ecosystems, and how it is being utilized in the traditional machine learning algorithms. So I'm Ritesh Yadav. I'm currently working in Intellect Design Arena. So my day-to-day job responsibilities include working along with various vertical teams, whether the core engineering team and the platform AI team, and DevOps team, to bring the solution mostly to the banking clients, wealth clients, into the production. Okay. So I've also worked onto this particular Gen AI domain, which is the day-to-day job of mine. And along with this, I'm mostly aligning to this Kubernetes and Docker and those all particular tools which are being utilized in the DevOps ecosystem. So let's begin with this particular session. Okay. So the agenda for this today's session is to give you the understanding regarding machine learning life cycle. So you all have gone through different set of algorithms in machine learning. You have seen different set of notebooks in Kaggle. You have seen different set of tools and frameworks which are being utilized in the machine learning ecosystem. There are different set of models which we are using to bring to create different sort of solutions for let's say house price prediction. Let's say if you have solved this particular famous problem, which is Titanic survival data set. So that is a good starting point for anyone who is getting into this machine learning or deep learning particular things. So the first thing is we are going to take a look is onto the overview of machine learning lifecycle. The second thing is what are the general challenges that we face, building a small project, building a project for your college projects, or building the project in a team or a hackathon project is very much different when we are building a production grade application. Okay. So anyone can build this basic POC, anyone can bring the ML models, anyone can bring the logistic regression and do the particular regression analysis, or do the particular classification kind of thing, or classify the images using convolutional neural network, or build an end-to-end chatbot using LangChain or any sort of GenAI platform. But the thing is when it comes to productionizing your application, okay, putting your application to the real world. Let's say if you see in the Netflix, so Netflix has their own recommendation system. Okay, so the movies that you are watching or the web series that you are watching in Netflix or in Amazon Prime, so they have this particular recommendation system which will give some sort of like a, a, a common recommendation for the type of genre that you are seeing in the Netflix. Okay, or like for the type of web series or the type of a category of a web series that you are seeing in the Netflix or Amazon Prime. So that sort of recommendation engine anyone can create. Okay, that sort of anyone can create, but scaling that particular recommendation engine and making it too much efficient that it can handle the load all across the world for different region, for places where we have low set of internet, low latency, where we have high latency, like you are not getting to good bandwidth of internet. So there also like Netflix loads up quickly. So creating that kind of systems, creating that sort of recommendation system is pretty much a kind of a difficult task in the real world. So there are different set of challenges that we face. So we are going to discuss regarding the challenges, and then we'll see like why we need MLOps, like what is the main requirement of MLOps, okay, and where MLOps comes into the picture, like why we need it, and then some difference between MLOps and DevOps. Like the people who knows about DevOps, like you are contributing to this particular open source projects. Okay, and in open source projects, you are having different sort of like CI/CD checks. You are having like some sort of continuous integration and deployment pipelines. Okay, you are having some sort of unit testing in any sort of project, like whichever you are contributing. So let's say if you are contributing to a particular like CNCF project, like Kubernetes or Knative or any sort of project, you, so you will be having some sort of like different sort of CI/CD checks that you need to pass it. Okay. So at that time, like here DevOps comes, like DevOps you have different sort of CI/CD pipeline created using Jenkins or GitHub CI/CD or Travis CI/CD, and different sort of unit tests which are going to be run along with the new and latest commit that you are going to make, or any sort of pull request that you are going to raise. Okay, so and the fourth point is like the fifth one is MLOps automated pipeline and its components. So what all components we are going to have in the MLOps pipeline, and at the end some sort of small summary regarding MLOps, and then we are going to see regarding how MLOps is different and what is LLMOps, and what is prompt versioning. Okay, how you can version different sort of prompts. So this is the particular agenda that we are going to see. The main intuition behind this is like to get you into the MLOps. If you see any sort of the projects which are available, like if you open the GSoC site or any of the open source projects, so you'll be seeing like a lot of places like people are getting into this generative AI ecosystem. People are getting into this particular creating the RAG based systems, retrieval based system, or multi-agent systems, graph based systems. So at that place, like to contribute to those all projects, you need to have a understanding regarding MLOps. Or another thing is like if you're joining anywhere uh, as a data scientist, like as a data scientist, you are joining in a particular team, then you need to collaborate with the DevOps team to productionize your particular product, to productionize your particular application. So at that time, if you have a little bit understanding regarding MLOps, so it will be helpful to debug the application, to get the logs without depending on the DevOps team to help you through. So let's begin with this overview of machine learning lifecycle. Okay. So I will be real quick here. So machine learning, like what do we see? Like, so there are a lot of components we are going to have. Like machine learning is not about just writing the code. Don't consider machine learning. Consider like machine learning, deep learning, or NLP or Gen AI. Is not about writing the ML code. So whenever we are building the building the application for our own purpose, then we just open the Google Colab notebooks, open any sort of Jupyter notebook, and we create the application. Okay, we create the particular. Okay, we write the code in the cells, and okay, this project is done. Or the next step, what we go is we create the fast API endpoint, we create a REST APIs, or like we create a Flask endpoints and create a Docker image and create an end-to-end project. Okay, but in real life, like there are, when you are productionizing a heavy machine learning application, okay, consider various recommendation systems. So recommendation system, and another thing is like some sort of like let's say in Amazon you have product recommendation based on your search categories. You will be getting different set of filtered products. Okay, so at that time, like your application needs to be faster, your application needs to be scalable and fault tolerant. Means if I'm having like big billion day sale in Flipkart, or if I'm having like some sort of sale in Amazon, so at that time, like the daily active users will be in millions, not in millions, like more than millions. Like every single hit, or every 15 minutes you'll be getting a lot of hits onto your application. So at that time, your recommendation system or your recommendation engine, or your some sort of like intent classification module should not fail at that place. Your ML code should not fail. Okay, your application of microservice should not fail at that point. So to handle those all things, there are a lot of there are different set of procedures that we follow, and that is called as MLOps, to give you a rough understanding. Now, so this image indicates like what we generally do. We take the XGBoost model or random forest model, and we create the application, take the data, perform some sort of data cleaning, data pre-processing steps, and then we create the ML code, and that's it. Okay, so we have completed our own project, and that's all. Okay, so this is a small thing what we do. But building this ML code is not only the single thing that we need to focus. Okay, in real world systems, what we see is ML code is a very small part. It is a very small block. Okay, so we have a lot of different modules which are working along with this ML code to make your application end to end. So we have the data collection module, we have the data verification module, we have the monitoring module, we have the analysis tool, and so on. So there are a lot of different set of modules which are working together closely to bring your application in live in production. Okay, so data collection is one of the module. Serving infrastructure, like you want to serve your application. Now, which infrastructure you prefer, whether you go to the AWS cloud platforms, or whether you go to the Azure, whether you go to the Google cloud platform. So different set of serving infrastructures you need to see. You need to do a rough comparison between these all serving infrastructure, and then you need to come to a conclusion. Okay, so this is the best suited infrastructure or best suited cloud platform that we are going ahead. Okay, and another thing is like monitoring your application, whether your application is working fine or not, whether it is facing any sort of bugs or any sort of failures in the real time. So when you deploy your application in real time, and let's say you thought in the first day 500 people will come, in second day 1000 people will come, and third day 5000 people will come, but you are not scaling your application based on the threshold, based on the number of users which are coming up. So at that point, what you need to say is you need to do some sort of load balancing. You need to do some sort of scaling strategies. You need to scale your application step by step from 500 to 1000, 1000 to 2000, and so on, so that it can handle such amount of traffic onto your application. So let's say on the first day, you are having a single instance of your application, a single version of your application. In the second day, you will be launching the two replicas of your application based on the crowd. Okay, so like that, you need to scale up and scale down your application based on the traffic which is coming up. Okay, now feature extraction. Feature extraction means uh, we all have seen in the COVID. Okay, before the COVID, the pricing of the houses. Let's say if you go to a particular locality and you query to the particular people who are living there, and you query for the particular flat, let's say before 2019, so you'll be having a different statement of prices. Okay, different statement of prices you are going to have. But if you ask the same price of that particular flat in 2022 or in 2023 after the COVID, then the prices of that particular flat is being hiked up. So this is because different set of features, uh, different set of categories, different set of features has been changed throughout the any sort of like calamities or any sort of uh, disasters. Okay, so at that time you need to update the data periodically. You need to update the data in a particular threshold, so that you can get the latest data and you can train your model and update the version of your model, ML model, so that it can perform in real life properly. Okay. So these all are the things like which we need to see. ML code is just the small part, or you can say your GenAI application which you are building up. You are loading different set of documents, complex documents. Let's say you are creating a particular application for the banking client. So in banking client, what they have is like they have different set of loan documents, different set of insurance documents, and you are going to load that particular 2000 to 3000 pages of document, and you want to do some sort of conversation with the document. You want to retrieve the important information like invoice ID, or whenever my insurance is going to expire, or what is the best premium that I need to select. So at that time, you need to go to the complex unstructured tables, different set of tables you need to parse it. Okay. And you need to utilize different modules like LangChain, Llama Index, or to create this retrieval pipelines or multi-agent systems using Crew AI. But at that time, you can easily build this particular application. Okay, that is again the GenAI application, you can easily build it. But putting it to the production is a difficult task. Okay, how to load such heavy models if you are not using OpenAI models or Bedrock-based models, or how to monitor your GenAI application. Okay, how to capture the logs, what is going on behind the scene, how the prompt is getting formatted. Okay, how it is what all context is being retrieved by the retriever. Okay, and whether my correct embeddings are getting vectorized in the vector store or not. So you need to take a look onto those all things to come into the conclusion why your application is not working. And so those are things you need to see, and then we can put the application to the production and go ahead. Okay. So in the real world ML process, again, this is a simple pipeline. You'll be understanding the problem. You'll be understanding the business need, what business need, and then you need to understand the data. Okay, you'll be understanding the data. Then you will be collecting the data and analyzing it. You are going to perform EDA kind of task, like exploratory data analysis, removing the unnecessary columns, making the data linear, so that your model can understand it. No matters whether it is a ML data, or like numerical data, or text-based data, or some sort of complex unstructured documents like business deals, or like a loan insurance based documents. So the pipeline will remain same. You are going to train a particular model. Now with GenAI, we are not training any sort of models because those models are very much heavy to train it. So what we do is we generally take the APIs. We take the API from OpenAI. Let's say if I want GPT 4.1 or GPT 3.5 turbo-based model, so I can just go there and take the API key and load it in the LangChain and just create a GenAI application. Similarly, for the Bedrock or any sort of like DeepSeek-based models, so at that time we don't need to do the any sort of model training, because training the model and doing the fine tuning will require a lot of compute. Even fine tuning require a lot of compute. You need to unfreeze the layers, you need to use the trainer modules, and you need to just train the particular set of model. Okay. So at that time also, like you need to have the particular set of GPU instances, or you need to have some sort of like even if you're training the quantized version, like if you're utilizing the C++ based models, so at that time also you need to have a good CPU strength to do the fine tuning. Okay. So it can be possible. Big firms like Nvidia and those are like uh, different sort of like big data centers are doing this sort of fine tuning. So they are the provider. They are providing different set of models. Like they are launching Llama 4 based models, or like Facebook Meta is launching these all models. So they have the capability. They are launching it. Small firms don't have the capability. That's why they take the open source models from Hugging Face, or they take the quantized based models. So when I'm saying quantized means those can run in the CPU. Like you don't need the GPU machines. Okay. So like, but at the end, there's no competition with OpenAI based models in terms of latency, in terms of performance, in terms of any sort of task, like whether it is a text based task, or whether it is a vision based task, or any sort of task. So that's the thing. So this is a pipeline which will fit mostly across machine learning based systems. If you're creating a deep learning based systems where you are using convolutional neural networks, you are using like ResNet or any sort of model there to process the images, the complex images, or you are creating some sort of like summarizing, doing the text summarization or part of speech tagging kind of task. So at that place, like this particular module is enough. To this particular structure is enough, like real world ML process. So here you have feature engineering, model training, model evaluation, evaluating the model on different metrics, and then deploying the model. Now, once you have deployed the model, you will be understanding the drift, whether your data is changing or how the data is changing, how the model is performing in the real life, okay, in the real ecosystem. So those all things are there. So you need to check the data drift, how your data is being changed uh, ac- according to the environment. So let's say there are few data sets, like few set of data which is going to change after this particular war which is happening, okay. So at that time, like you need to see like, okay, so this is a data set which is being changed in 30 days, in 40 days, in 50 days. So I need to train the new version of a model and put to a production. Now, so at that time only MLOps comes into the picture. So you don't need to do any sort of step manually. So you don't need to train your model again and again. Let's say you have a data set, you have X, Y, Z features. Okay. In the new data set which is coming up, that is also have X, Y, Z features. Okay. So X, Y, Z are the strict columns. Means these are the names of the columns. So you need to keep the names of the features or the column same. You just need to create a particular pipeline where your model will be automatically trained. A new version will be produced, and then you will be doing some sort of test in locally, and then you will be putting into the production. So you don't need any sort of manual intervention or human intervention in between for this particular step. So health dashboards and reports. So health dashboard and report, these all are going to tell you whether your model is working or behaving in the real time uh, or not, whether it is behaving perfectly fine, whether it is giving accurate results or not. So you have different set of metrics. In machine learning, you have F1 score. Okay, you have ROC, AUC curves. You are having accuracy. You are having precision recall. In deep learning, you are having different set of like classification accuracy and sort of uh, how closely the image is being generated. Okay, so you have different set of parameters. In NLP, you have rough score, blue score, different set of metrics you are having. You'll be judging onto those all metrics, and you'll be sending the particular report. Okay, this model is being degraded, upgraded with the latest set of data. This model is fine. Okay, let's say below 80%, your accuracy is going below 80%, your model is getting degraded. Okay, this is a common threshold that we usually set. Above 80%, everything is fine. No machine learning model or any sort of data science model can be 99% true or 100% true. If you're getting 99% accuracy, 100% of accuracy, then there is some problem with the model. Okay. It can, the good threshold which we considered is 95%, 96, 97, 98. That's it. Okay. Any, any type of AI model, any type of data science model can't be 100% true. Okay. So there are a lot of things like that you need to see here. Like you will be having a model management. You will be versioning different model, version 1, version 2, version 3, version 4. So to manage the different version of model, let's say your version 2 model is not behaving well, latest version is not behaving well. So you can revert back, roll back to the version 1. To roll back to the version 1, you need to have a particular store, model registry. So ML flow is one of them. ML flow, if you go and search, ML flow is one of them to track the experiments and so on. Okay, so there are a lot of steps out there. Now, challenges with ML during the model, during development. So what are challenges we are having? So we are having development, training, and deployment environment can be different. Sometimes like you are developing in Linux, someone is someone is testing your application in Windows machine. Okay, your deployment environment is Ubuntu. Okay, so there are a lot of different variation between the environments. Okay, sometimes. And then you are having tools, libraries, and dependency. Let's say I'm using sklearn version 1.0. My another teammate is using sklearn version 2.0. Okay, so there can be different set of tools and libraries. Okay, different version of libraries that can become difficult and complicate while while building a particular ML machine learning model during development. And tracking and analyzing experiment means, let's say, I utilize from, let's say there are 10 features are there. I'm utilizing 8 features and I'm getting 99% accuracy. My friend is utilizing 5 features. He's also getting 95% accuracy. Okay. So different set of features you need to track. Okay. These features are important for my model. This experiment is giving me 95% accuracy. This experiment is giving me 96% of accuracy. Let's say in machine learning models, if you see random forest, number of trees, you can define different set of hyperparameter. So while you are changing the hyperparameter, your accuracy will also getting changed. So you need to track the experiment. Okay. So I have done 10 experiment. I have done 10 experiment, and in 10 experiment, uh, the fifth one has given me the good result. So, but how I can remember? Like how I can remember? Like what is the parameter for the fifth one? Okay. So to have those all information tracked, you need to have a particular set of dashboard. So that dashboard is MLflow, which we generally utilize. MLflow is one of the dashboard which you can take a look. Difficult to reproduce the environment experiment as the input data changes. So let's say input data is changing. Your input data is changing in every 30 days, 40 days, 50 days. So you need to do the kind of some sort of pre-process, some common set of pre-processing, common set of data cleaning. Okay, to reproduce the same experiment. So how you can store those all particular pipelines. So at that time, different set of tools like Airflow will come into the picture. Okay. So where you can define a set of pipeline, whether the input data is changing, you just need to keep the column name intact and your pipeline will be running. So let's say first we are going to do data pre-processing, data cleaning, and then we are going to train the model. Then we are going to test the model, and then based on the testing result, we are going to put the model to the production. So like that. So at the end, if you're going to see like at the end, like when you're building a ML model, you're developing it. Sometimes like if you don't have these all things, it will be kind of a jungle kind of thing, like where you are messed up with a lot of things. You need to do the development, training, deployment also. You need to version the libraries also. You need to track the experiments also. So currently, like see, if you are using Jupyter notebooks, if you are using VS Code also, so we just do pip install langchain. Okay, we don't give the name of the version which you need. But whenever you are putting the model in production, whenever you are putting the machine learning application in production or any, you need to mention the version. You need to hard code it. Because let's say your friend has installed the latest version and you have installed version 1, then it will be difficult. Some features are not there in the version 1, some features are there in the version 2. So every time whenever you're defining a requirement.txt file, so you'll be mentioning like langchain equals to 1.0, so that everyone in your teammate can install that particular set of version. Okay, so that's the thing. That's why we utilize this Anaconda or Conda to have this particular environment to be created. Now, some more challenges like live data is not equals to the training data. Like in the current application which we have deployed, sometimes people are putting random number. Let's say your application is giving some sort of uh, based on the different set of features of a particular house, it is giving you the results. Okay, it is giving you the prices of that particular house. But let's say people inserting the string in the place of integer. Okay, in the while they are filling the information. So at that time, like you'll be getting an unknown set of data type there, like different set of data type. So at that time, prediction won't happen. They will be getting some sort of wrong prediction, or they will be getting some sort of error. Okay, so that's the thing. So live data is not equals to the training data sometimes. Similarly, like feature engineering pipeline must match between training and serving infrastructure, correct? So you'll be having a same feature engine, means the same features which you are extracting. It should be same in the training also. It should be same in the deployment or serving. When you are deploying your application, it should utilize the same set of features to get the response also. Then seamlessly scale up and scale down. Correct. That is what we have discussed. Like consider the example of Amazon or Flipkart, where you are having a lot of traffic onto the recommendation system. So you need to scale up and scale down based on the different set of users which are coming up. Another thing is like continuous training and champion challenger model, means the best model you need to version it. The best model you are going to launch it. So how you are going to do that automatically? Manually, you can do that. Anyone can do that manually. Okay. But you can't do that manually 100 times or 200 times. You need to have an automated system where the best version of your model will be deployed. with the latest set of data trained. Okay. So, and different technology landscape between deployment and development. Correct. That some places like let's say someone is using Ubuntu, someone is using Windows, someone is using different version of package, someone is using different version of package. So we need to make sure these all things will be resolved with the MLOps. Okay. Now, this is a general team structure. Okay, general team structure. When we discuss about when we work in a particular team, so you're going to have a data engineer, you are going to have a data scientist, you're going to have the DevOps engineer. Okay, so problem framing and understanding, you can see like data scientists coming to the picture. Then we have the data acquisition and creation. You are having data engineer. Then we are going to have this experimentation. So we are going to have data scientists. The different phases of pipeline, we are having a different phases of people or the engineer team which is working. Okay. So we have data engineer, we have ML engineer, but how to unite them? How to share a common common board where they can come and put their thoughts. Uh, we we should work in a particular pipeline kind of thing. Like so, at that point, MLOps is a place which will help us to integrate data scientist, ML engineer, data engineer, DevOps team to work together to bring up a particular solution to the production. Okay. Now, what is MLOps? MLOps is simple terms is DevOps for machine learning. Means if you're having like some sort of like what is DevOps? DevOps is like development and operation. Okay, you are going to develop a particular application. So there is a development team. Okay, so software engineer is a developer. Okay, so people go in SG position. So those are developers. Operation team is like which is going to deploy your application, which is going to productionize your application, which is going to monitor your application end to end. Okay, so that is a DevOps team. Now, when it comes to the MLOps, now what we have done is in the place of developer, we have added the ML. And the extra thing which comes into the picture is uh, 1 minute. The extra thing which comes into the picture is we are having the model, we are having the data. Okay. DevOps is same, like they are going to create the particular application and they are going to release the particular application to a particular stages like dev, QA, and so on. But machine learning is the particular set of branch which comes into this particular pipeline, which will have the model, which will have the data, which will have different set of features. So machine learning, when we add machine learning in DevOps, it will become uh, MLOps kind of thing. So MLOps enable data science. The same thing is written here, and IT teams to collaborate and increase the pace at which ML models can be developed, deployed, and scaled. Monitor. Okay. Now, one more thing which make this MLOps different from DevOps is retraining. Okay, so retraining means launching a new version of a particular model based on different set of, let's say your data is changing, let's say your model is getting degraded. Okay, it is not behaving well in the production environment, or it is not giving the correct set of information to the end users. So at that time, what you're going to do is you're going to uh, deploy new version of model, retrain the model again. So when we add retraining, when we add the machine learning, then we come up with the particular term known as MLOps. And people are discussing regarding LLMOps, so nothing. It is exactly same. Remove machine learning, add large language models there. You are having LLMOps. Means at that time we are having generative AI ecosystem, and we need to deploy and we need to productionize the Gen AI application. Means the retrieval based application or multi-agent application, multi-agent systems we need to publish, or you can say like any sort of like the latest things like model context protocol, MCP servers we need to publish. So at that time we are having some sort of pipeline known as LLM. Okay. Now, how MLOps is different from DevOps? Again, data versioning apart from code versioning in DevOps, you are having Git. Okay, you are utilizing the GitHub. We are utilizing the GitHub. Here also, we are having different set of tools to version the data. We are having Databricks. Okay, we are having Azure Data Factory. Okay, so at that place, we are going to version the data. Let's say I'm working with a particular vendor who is going to provide me the data in every 30 days, a new data. So I need to version it properly. This is a version 1, this is a version 2, version 3, version 4 of a data. So this is the extra step which adds on in the particular MLOps pipeline. So we have the data versioning except the code versioning. Okay, code versioning, we are going to do it. Okay, but we also need to version the data properly because data is the sole truth for this machine learning and any sort of data science. Okay, without data, you can't perform any sort of activities. Experimentation tracking. Okay, let's say you are playing with the parameters, hyperparameters. Now, what are hyperparameters? In random forest models, you are going to see number of trees. Okay, depth. So those all are the hyperparameters. Okay. So you can change the default hyperparameters and you can get the better results, or you can get the worst results based on the uh, size of the data. There are a lot of factors which depend. Only tweaking the hyperparameters won't help you there. So you need to see a different set of things. Like your data should be properly formatted, properly cleaned, properly EDA should be performed. Your data should have the it should not be imbalanced. Means let's say you have the positive value more, negative value less. So it should be balanced out. Now next thing is like model artifacts. Like the saved model, you need to version it. Saved model, metadata files, you need to version it. You need to monitor it continuously. For let's say your data is changing, you need to retrain your model. Continuous retraining means you need to retrain the model to produce the best model or the champion model. You need to produce it. So for that, you need to retrain it again and again. Okay. Now, ML plus DevOps, that's it, the same thing. CI, build, test, and validate the code. Continuous integration means you're going to run the unit test cases. You're going to build unit, you need to run the unit test cases. CD means you need to deploy the and serve the application for inferencing, some sort of ML training pipeline plus serving component. CT means continuous training. Based on the new data, based on the latest trend, you need to train the model continuously and serve the model. Okay, so that is the CT part. Now, again, this is a pipeline. This is the MLOps pipeline kind of like, so what you're going to have here is you are having the data analysis step. You are having some sort of model analysis. Then you are going to publish the source code to the source repository, means GitHub. You are going to build the test cases, then you are going to package it and you are going to deploy it through the continuous deployment. You're going to serve the pipeline. Now, to monitor the particular to monitor the ML machine learning model, you can monitor the Docker containers, you can monitor the Kubernetes pods. Okay, so you can monitor your application end to end using different set of tools. So if you see, you are having Grafana, you are having Prometheus. Okay, so you can use those all tools to monitor Datadog. You can utilize to monitor your application real time performance, how it is working, whether it is working fine or not. Now, feature store, what is feature store? Feature store is a place, let's say you're working in a particular team, you are 10 to 20 members, and you want someone has performed data cleaning, they have collected the important set of features which will impact the result for that particular model. So those features you will collect it and you will put it in the feature store so that everyone can take all those features and train the particular model, different version of models, and experiment it. So you don't need to do the data engineering again and again. The feature store will store version the features. Okay, so you can store feature 1, feature 2, feature 3, feature 4, feature version 1, feature version 2, feature version 3. Okay. Now in LLMOps, the same thing, the feature store will be replaced by prompt store. So you are having different set of prompt templates. Okay. Prompt template version 1, prompt template version 2, prompt template version 3, and so on. Okay. So that's the thing. So feature store will be replaced by prompt templates, prompt store, and so on. And then you are having this in the place of like model training, you are having like testing the model with various prompt templates. One which is going to give you the best retrieved results, like the best retrieval score or some sort of relevancy. So those are the metrics which we have in the LLM. So when we are building a retrieval RAG-based system, retrieval augmentation generation. So there you don't need to train the model, just take the OpenAI API key and then plug it and test the model. How it is retrieving. You need to create a retriever through LangChain. So you don't need to do this training of a model and do so. You just need to create a RAG application, serve it, and then update the vector store with the new set of knowledge base. You need to update the set knowledge base again and again with new set of documents, and just you need to you can deploy a new version of application. This is valid for this particular pipeline is valid for ML and deep learning and NLP use cases where you need to train the particular model or fine tune a particular model. Okay. Now, the overall end summary is you can see like you need to define a particular problem. Okay, so see this MLOps is not the thing for this for particular uh, POC projects or self projects or any sort of like your personal projects. It is a kind of enterprise grade thing, like where you want to productionize the particular application to the end users, where they are going to utilize it for their own use case. At that time, you need to deploy your application end to end. The normal MLOps pipeline, if you want to build, what you can do is you can create a particular, consider a basic ML application, create a ML application, attach ML flow, version your model, different set of model. After ML flow, package your application, create a container, Docker image. After Docker image, work with Kubernetes, use Kubernetes to deploy your Docker container, Docker image, and then see how your application is working, how your application is behaving. That's it. Okay. Or you can, another thing which you can try is create the GitHub CI/CD pipeline, GitHub pipeline. Okay, CI/CD. That is a free thing which you can utilize. Okay. Now, the overall summary is like we need to define the problem statement every time whenever we are building a particular ML application. Data collection we are going to do. We are going to do the data processing and storage. We are going to define the metrics, different set of metrics. We are going to define it, and then we are going to perform some sort of data exploration, feature extraction, and model training. And at the end, model after the training, then we are going to deploy it and release a new version of a model and continuously monitor it, how it is behaving in real time. If it is behaving badly, if it is not giving you the accurate result, or if it is not working up to the mark, then what you're going to do is you're going to retrain the model. Okay. So that's the thing. So to see the MLOps, sorry, LLMOps, you can go to this particular site, Neptune AI blog. Let me do one thing. Okay, so it has most of the details like what is MLOps and why MLOps is different, how it is different from MLOps, and what are the three levels of large language model operation. Like large language model API, you are having fine tune and serving the large language model, train and serve the large language model. Okay, now what all different things we have? We are having prompt engineering, we are having LLM chains and agents, we are having serving and observability framework. Okay, so these all are the components in LLMOps what we are having. And then prompt engineering, creating a particular contextual prompts, scaling it, and creating effective prompts. And at the end, updating the vector database again and again and performing the LLM evaluation. So this is there's nothing different in LLMOps except you are having the large language models there, and you are having prompts and you are having vector stores. That's it. In the place of machine learning, in machine learning, we are having some sort of database where we are storing the CSV files, where we are storing different set of data. Here we are having uh, vector stores like Quadrant, like Chroma DB, and so on. Okay, here we are having prompts. There we don't have nothing like prompts. Okay, so we need to version the prompts. There we are versioning the data, but data version 1, version 2. Here we are versioning prompt version 1, prompt version 2, and so on. Here we are having LLMs. There we are having ML models. ML model require training. LLM doesn't require training. They are self-sufficient. Like OpenAI has a great API set, like GPT 4.1 model, 3.5 model, and so 4 more based models are there. And Bedrock has Sonnet and Haiku based models, so you can utilize that. So this is the difference between LLMOps and MLOps. So the main thing is like if you want to see the basic pipeline, you can take a look. You can create a particular Docker container, deploy the Docker image, and then you can just see how you can integrate ML flow in it, how you can integrate Kubernetes in it, and so on. Okay. So this is the idea regarding what we have discussed is MLOps and LLMOps. Yes. Yeah. Thank you. Any question? Yeah. Yes, please go ahead.
Wow, that was such an insightful session. Thank you so much, Ritesh, for breaking down such a complex topic so effectively. So then let's now move into a short conversation with to learn more about his journey, experience, especially in the open source. So we have few questions like
Sure.
we know you have been actively involved in open source, right? Could you share a bit about your journey in the open source world?
Yeah. So in open source, I started with this particular Cloud Native Computing Foundation. In Cloud Native Computing Foundation, there are some like beginner-friendly organizations which we are having. So when I say beginner-friendly, like there are some organization like Meshri, you can see. Uh, Meshri, you can see, and you can see this particular organization named as Porter. So I was the maintainer for this particular organization. And another thing is like you can go through. So the main idea is like to understand the complex code to solve any sort of issues which are raised in a particular platform. So what you need to see is you need to understand the particular module and particular code, and you need to see how you can contribute it. The best way to contribute is to engage with the mentors, engage with the maintainers which are there, to understand their idea, their thoughts, how they are going to resolve this, and step by step break down the process, get into the particular module, and see uh, how you can resolve this particular issue. Okay, so the thing is like the more you go and get into this particular code, the more you understand different writing patterns, code structures, the more you get about that particular issue which is being raised. So there are some beginner friendly issues which are being raised in all the organization. So if you see this Meshri one, if you're interested in cloud, then take a look onto this Meshri one. Meshri is one of the beginner friendly organization. Another one is like you can take a look onto the small scale organization Cloud Native Computing Foundation. Small scale, like if you're interested in cloud, if you're interested in any other particular tech like Node.js backend or TypeScript, those all things, then there are a lot of organization like you can take a look. But the main idea is to break down the code and get into this particular issue and connect with the maintainers. Yeah, that's it.
Yeah, nice. Thank you. And we also know that you are a alumnus of GirlScript Summer of Code back in 2021. You have
Correct.
served as a mentor. So
Correct.
could you please share your experience, how it helped you shape your current path?
Yeah. So at that time, like, see, at that time, like, in GirlScript, like, I guess this GirlScript Summer of Code is going way back before I joined my graduation. Also, like, so it is a very old program. Like, it is not 1 to 2 years. It is like many years old program, like 8 to 9 years. Like, many lot of people have been contributed to it. So the best way is like lot of people comes with their own open source projects. Like those are not small scale, some are small scale, some are large scale, which will give you a rough understanding regard and prepare you for the larger programs which are already there, where you can get into larger set of code. But to understand those all code, you need to see these small codes like writing patterns in TypeScript and different set of tools and technology which the projects bring in this GirlScript Summer of Code. So what I usually do is like I was contributing in GirlScript Summer of Code in 2021. There were multiple 2 to 3 projects in which I have contributed, like which are closely to my domain. At that time, I was working in this Android. So Android is the domain which I'm working on. So at that time in 2021, so there I contributed to some of the Android-based application, and I also contributed to this basics like TypeScript and Java, TypeScript and HTML, CSS part. So that's the thing. So you need to break down the organization, select the common organization which aligns to your role and uh, particular technology which you are interested in, and then you can contribute it in slowly and slowly. Yeah.
Thank
Yes.
you. Soon, actually, we are soon launching our next edition of GirlScript Summer of Code 2025.
Great.
Yeah.
Great. Great.
And so let's pick some question that we got from the Q&A form. One of the person asked like, how do you monitor and retain models when data pattern changes over time?
Okay. Okay. So see, to monitor and retrain the model, to monitor the application, monitor the model, you need to set up some sort of evaluation metrics, some sort of thresholds. Okay, let's say the basic, we go with basics, like you are having like accuracy as a evaluation metric. So you'll be utilizing accuracy as a evaluation metric, and you will be checking like in real time whether your application is going beyond 80% or below the 80%. Based on that, you'll be triggering the retaining module. Now there are different set of metrics are also there, like covariate shift is there. So evidently is one of the module which will help you to monitor your application and retain your application. It provide different set of metrics. So you can take a look onto the evidently. So that is going to provide you end-to-end solution for monitoring and retaining your application. Yeah.
Thank you. Audience, if you have any questions wanted to get answered, please do comment.
Yes, please. Any sort of questions. If it is a basic, no issue. Every question is welcome. Yeah.
Yeah, I want to ask a question from the
Mhm.
audience itself.
Please.
So if anyone wants to start their career in LLMOps or MLOps, how can they start as a fresher?
Correct. Correct. As a fresher, see, the main idea for this MLOps and LLMOps is if you want to start with in career in this particular field, start the career in data science. Okay. If you're starting the career in data science, you'll be already getting the exposure to the MLOps. Definitely, in any of the firm, if you're working, you will be getting the exposure to the data science. It is impossible, sorry, in the MLOps, it is impossible if you're not getting the exposure, because everywhere, if you're in a startup, if you are in a big firm, in a tech giant, you will be getting, you will be communicating with the deployment team, the DevOps team, and putting your, you need to give them a description, what you need to deploy it, how your application look like. So you'll be getting the exposure to the MLOps, and slowly you can shift from data science to the MLOps. Getting into the MLOps and LLMOps in the as a fresher, it is little bit difficult, not tricky. It is little bit difficult because it requires some experience in the DevOps field, plus in the machine learning field. So the best way is to get into the data science, and in data from data science you can get into the MLOps and LLMOps field, because everything is LLMOps, so you'll be getting into the LLMOps mostly. So that's it.
Thank you.
Yeah.
Okay, let's end. Thank you for the session. A big thanks to Ritesh for sharing such a valuable insights. And thanks to GirlScript Foundation for launching education outreach program to empower more learners. We hope this session inspired you and we're looking forward to coming sessions. Thank you.
Yeah. Thank you for inviting me. Like, I appreciate